Chemistry Try lessons. Today we're going to talk about the structure of the atom. Now, one of the things you need to make sure that you can remember, and you should remember this from middle school, is that an atom is the smallest particle of an element. I can't break it down any smaller than an atom, and that element still contains the properties that it has. If I took an atom of gold and I broke it down and said, okay, I'm going to break it down to its protons, neutrons, and electrons, it will no longer have the characteristics of gold. But in that right recipe, that correct recipe that gold has with the number of protons, neutrons, and electrons, it acts as what we know as gold. So an atom is the smallest that an element can be broken down and still contain the physical and chemical properties of that element. Now, as we can see here, an atom is made up of electrons, protons, and neutrons. The protons and the neutrons are inside the nucleus, which is the center of the atom. And actually, that's where all the mass is. The electrons, which are extremely small, will be in a cloud, if you will, around the outside of this nucleus. So they're going to form this cloud around the outside of this nucleus. And whereabouts that cloud is will determine on the amount of energy that that specific electron has. I'm not going to get into real deep level about electrons. Electrons are one of those strange things that we still don't know a whole lot about in science. It can be in two places at the same time. It doesn't move from one place to another. Whether it goes from one dimension or another, we don't know. We just know that electrons are on the outside of the nucleus. They're held in that cloud by the pull of the protons. Okay, so these protons are extremely important. They're the ones that are actually holding the thing together. The electrons are the ones. So when we look at these electrons in through here, the electrons are the ones that are creating all of the chemical characteristics. How something is going to react, how something is not going to react, all is dependent on the electrons that it has. Neutrons are the same size mass as the proton, and they reside strictly inside the nucleus. Now, when you go to college and you take a different class, you're going to be, hearing things like, well, we can break the protons and the neutrons down smaller and smaller. And yes, we can. We can go to quarks, we can go smaller than quarks, like a neutron and a proton are made up of, two up quarks and a down quark and all of this stuff. We're not going to get involved in that level at this class. All you need to do is remember, okay? Right down here, all you're going to do is remember that you're looking at protons, neutrons, and electrons. Nothing smaller than that for this. Now, when we take and look at this artist's rendition of an atom, the nucleus is very, very small in comparison with the size, overall size of this entire atom. But remember, as we talked about this is an electron cloud. So these electrons are in this cloud that are around this nucleus. And electrons have almost no mass. A little bit, but very, very, very small mass. Most of the mass of an atom is contained within this nucleus. Now, hydrogen is the smallest, and if we take a look at the periodic table, which we'll see here in a minute, you'll notice that it has one proton. Here is a symbol that we have pulled off the periodic table of carbon. That's its elemental symbol right here, shows carbon. That's what the C stands for. So we know that when we look at this is carbon. We can see up here in the corner on most of them is the atomic number. The atomic number for carbon is 6. What the atomic number tells us is number of protons. Two elements cannot have, I want to repeat that, two elements cannot have the same number of protons. So whenever the number of protons changes, you have a new element. Now down here at the bottom, as you can see, we have something called the atomic mass. This is what this weighs. If we were talking one atom of carbon, this would be 12.01 atomic mass units for each atom. If we're talking about 1 mole, which is a different lesson, because remember a mole is 6.02 times 10 to the 23rd atoms, which is a whole bunch of them. If we're talking about 1 mole of carbon atoms, then this would equal 12.01 grams, which is how we will talk about molar mass in the future. Okay? All of this weight, all of this atomic mass right here is determined by these protons and neutrons. Okay? So right off the bat, you should be able to tell me, well, if it's an even charge, no charge on the atom, then I have to have the same number of protons, because remember protons have a positive charge, electrons have a negative charge. So if that's the case, and this is an atom, which means no charge, an atom will have the same number of protons as it does electrons. The other amount of this weight, this other 6.01 that we see down here in this atomic mass deal, is what is made up by the neutrons. So I can take my atomic number, which is 6, take my atomic mass, which is 12.01, subtract that, and see that I have 6.01. We'll talk about the 0.01 in class. It really doesn't mean much. What this tells me is I have 6 protons, 6 neutrons, and since I'm at an even charge here, because it didn't say ion, it is an elemental form or its atomic form, I have 6 electrons. Now here's the periodic table that we use in class on all our tests and stuff, so you will see this a lot. But as you can see on each one of these, you can see that at the top is the atomic number. Here for hydrogen, the atomic number is 1, so that means it has 1 proton and 1 electron. Since its mass is also 1, that means it has 0 neutrons. Now let's go over here and look at the carbon, which we just looked at. As you can see, atomic number 6, 6 protons. If it's an even charge, which they all are on the periodic table until you hear the word ion, then it has the same number of electrons. And then there's our atomic mass that we used just a minute ago at 12.01 to determine our neutrons. So, if we was to take a look at, let's say, magnesium, its atomic number is 12. So its protons equal 12. Its electrons, since it is neutrally charged, its electrons equal 12. For me to figure out how many neutrons it has, I would take 24.3, which is its atomic mass, you can see there, subtract my atomic number, which is the number of protons, and come up with 12.3. Remember, the 0.3 is just something that is average out there, because you can't have a point of a proton or a point of a neutron. So that means I have 12 neutrons. And you should be able to do this for every one of the elements on the entire periodic table, because it tells you how many protons, protons plus neutrons, and if it's neutrally charged or 0 charge, then the protons and the electrons will be the same. Now I strongly suggest that you review this as many times as possible so you can feel very comfortable with this, because this is something in chemistry you have to do constantly. And it also helps to get used to looking at the periodic table, because one of the things that we're going to be doing a lot in the future is we're going to be looking at the molar mass of an element. Remember, always try, chemists try, never, never give up, and stay gritty.